Hello everyone, in this video we will still be having solving systems of linear equations, but this time we will do it by elimination using either addition or subtraction. On our previous video lesson, we did it by graphing. Let's have an example. Solve the system x plus y equals 5, x minus y equals 1. Here are the two given equations. From the name of the method that we will apply, elimination, we will eliminate one of the given variables. To do that, see to it that the variables that we want to eliminate have the same numerical coefficients. In this case, the numerical coefficients of x are the same. Subtracting the two equations will eliminate x. Also, the numerical coefficients of y are the same, but they have different signs. Adding the two equations will eliminate the variable y. Suppose that we want to eliminate y. Then we will add the two equations. Adding them will remove the variable y. X plus x, we have 2x. 5 plus 1 on the right side of the equation, we have 6. This equation 2x is equal to 6 will give us the value of x by dividing both sides by 2. Therefore, x is equal to 6 divided by 2, which is 3. To solve for the variable y, we can now use the solve value for x, using either of the two equations, whichever we think is the more convenient. Let's say we want to use the first equation, x plus y equals 5. Plugging x equals 3, we have 3 plus y equals 5. Subtracting 3 to both sides will give us the value for y, which is 5 minus 3, equivalent to 2. So therefore, x is 3 and y is 2, and the solution of the system is 3, 2. Therefore, we expect that the graph of these two equations intersect at point 3, 2. Let's have another example. Solve the system 2x minus y equals 3, 6x minus 3y equals 9. We were given the two equations, and as you can see, the variable x doesn't have the same numerical coefficients. Also the variable y. So we cannot add or subtract yet the two equations to eliminate one of those. To make the numerical coefficient of x of the first equation become 6 as well, let us multiply both sides by 3. 3 times the quantity 2x minus y is equal to 3 times 3. Applying distributive property on the left side, 3 times 2x, that is 6x, 3 times negative y, we have negative 3y is equal to 3 times 3, which is 9. Copying the second equation, 6x minus 3y is equal to 9. And as you can see, the numerical coefficient of x are now the same, but also the numerical coefficient of y. Subtracting the two equations will eliminate the two variables. We have 0 on the left side of the equation, which is equal to 0 on the right side as well, because 9 minus 9 is 0. But 0 is really equal to 0. If this is the case, then we can conclude that the system has infinitely many solutions, meaning to say the graph of these two equations coincide. So if we ended up at 0 equals 0 after attempting to eliminate one of the variables, then we can say that the system has infinitely many solutions. Let's have the third example. Solve the system 2x minus y equals 2, 2x minus y equals 3. Here are the two given equations. And as you can tell, they are the same on the left side. Meaning to say, if we will subtract the two equations, we can eliminate the variable x, also the variable y. So the left side becomes 0, while the right side is negative 1, because 2 minus 3 is negative 1. but 0 is not equal to -1. If this happens, the system has no solution. Meaning, if we will graph the two equations, we are expecting that they are parallel lines. So if we ended up at 0 equals to another number after attempting to eliminate one of the variables, then we can conclude that the system has no solution. And that's how we solve systems of linear equations into variables by elimination using either addition or subtraction. Thank you for watching. If you like this video, click on the thumbs up below. You may also watch our previous video for review, and I would really appreciate if you will subscribe to my channel.